So today we are going to learn how to remove the duplicates in place of a given sorted array. In place of a given sorted array. Let's try to look first to the brute force method. We'll discuss about first brute force method. So here we have given an array which is sorted and it contains duplicates 2, 2, 2, 1, 1, 3, 3. These are the duplicates. These are the duplicates. So when we should have to return the duplicates at first, and later it could be any value, it doesn't matter. So when you return all the duplicates in front positions of the array, then you should return the value of the array, the value of the duplicates. Here are the three duplicates. There are three duplicates. So one thing is really clear here is we should need to remove the duplicates from the array, and we should need to return how many duplicates are there in the array, right? Okay. What I'm going to do here is there are unique elements. There are unique elements in the array, right? For that unique elements, we use set data structure. So I'm going to use a set data structure. Okay. What I'm going to do here is I'm going to take this one and put it into the set. Okay. I'm going to take this one and put it into the set. Can I put this? Did the set accept this one? No, it doesn't accept because there is already one in the set, right? So, okay, I'll move to the next. I say 2, put into the set. Okay. I say 2. I say 2 again. No, there is already 2 present in the set. So I'll move 3. I'll put it into the set. Again 3. No, there is already 3 in the set. 3. Again 3. There is already 3 in the set. So the iteration is over. So let's try to write a quick code for this set data structure. Okay. Set of integer, a set. I'm going to write a loop. I is less than n and I'll increment. And I say set dot insert array of I. Insert elements into the array of I. So now I'm going to insert the elements in the set at the first positions of the array. So what I'm going to do here is I'll say index. I'll take it as index. Okay. I'm going to take this first one at index and I say here the index will be 0. Here the index will be 1. Here the index will be 2. Here the index will be 3, 4, 5, 6. So these are the index values. And I say the first at the first index the value should be 1. The value should be 1. At the second index the value should be at the 0th index the value should be 1. At the first index the value should be 2. At the third index the value should be 3. What happened here is I have go to the first index and I say at the 0th index the element was 1 and I increment to the next index and I say the next index element is 2. Then I increment the index. Then I increment the index and I say that the second index element is 3. So this is how we insert the values to the set. Let's try to write the code for this. I say index is equals to 0. Index is 0. I say for auto iterate. I'm gonna perform auto iteration to the set. I say and array of index will be it. Yes, and increment the index value. So okay, I'll say iterate to the set and insert the iterated value the set at the index, at the array of the index, and increment and again insert the element at the array index. So okay, let's try to find the time complexity for this. Since we have inserting the element into the set, then the time complexity will be we go of n logarithmic of n. So here the time complexity will be we go of n. Then the time complexity is we go of n logarithmic n plus n. Then what will be the space complexity? Space complexity will be big O of n. Why the space complexity is big O of n? Because if all the if the array if the given array have all the unique elements, for suppose like 1, 2, 3, 4, 5, 6. So in this way, all the elements should need the set have to store all the unique elements into the set, right? For that, it will take the time complexity of big O of n. So okay, now we are going to now we are going to see the optimal solution for this. How to remove the duplicates from an array, from the sorted array. Optimal solution. So let us try to understand the thought process first. So this will be the I pointer. So we are going to solve this approach using two pointer approach. That will using two pointer approach. So we're going to solve this using two pointer approach. That okay. Let's look to the thought process. Here what I'm going to do is, so I say this one will be the one, right? This one is sorted. I say, so what I'm going to do is, the first will be one only. Then what I'm going to do is, I'm going to check the remaining index. Is there anyone is different from the first index? If I find someone different from the first index, then I say, then the first index will be say, so you can take my place. You can be in front of my place. Okay. Then again, I'll move and I say this and I look for the different element. No, these are all the both same elements. Then I look for the different element. Yes, this is different element. So I say this can be in front of this element. So this is how we can sort the so this is how we can remove the duplicate elements in the array. So okay, let's try to do this using two pointers I, j. We'll use these two pointers to solve this problem. So okay, I will be here at the first and j will be at the second. I will say, so I'll find out, is there any different element here? No, one is not a different element. It's a same element as first index. So I'm going to move. Is this different from the first index? Yes, this is different from the first index. Then I'll say I will say you can take my place. You can take my place in front of me. Then I'll go to next element. Then I say j. Then I say first the I pointer will be at 2. Okay, the I pointer will be at 2. And we'll go to the next element 2. Are you different from 2? No. Then I'll go to the next element j. Are you different from 2? No. Then I'll go to the next element j. Are you different from 2? Yes, this is different from 2. Then I will say you can be in front of me, that different element. Yes. So here we have three unique elements. This will be the index 0, this will be at the index 1, and this will be at the index 2. The next element is same as that, so the iteration is over. Then we have got this unique elements 1, 2 and 3. 1, 2 and 3. So let's try to code this thing. I say I will be at 0. I will be at 0th index. Okay. Then I'm going to write a loop. For loop j is equal to 1, because j will be at the first index, right? And j is less than n, and j will increment. Then I say if array of I is not equal to array of j, because here 1 is not equal, here 1 is not equal to 2, right? Not equal to 2. Then I'll say array of I plus 1 is equals to array of I. Sorry, array of j, right? Because this is a j pointer, right? So what do we mean by this array of I plus 1? If 1 is different element from 2, then I is saying, so you can take my next position, that is I plus 1, right? That is I plus 1. That is I plus 1. So we'll just return the I plus 1. Okay. Yeah. Then we'll see what will be the time complexity. Yes, we are just iterating only one loop. So the time complexity will be big of n, and the space complexity will be big of 1 for sure. So this will be the optimal solution for this remove duplicates from